All right, stream 52. Today I'm going to continue my work on chunked transfer coding that I did yesterday. And two things on the plan today. I want to add some negative use cases to chunked body, which is the class I was writing to handle chunked transfer coding. Actually, it's just doing decoding right now. At some point we need to do encoding as well. But this negative use cases will be having it try to decode erroneous or buggy chunked bodies and verify that it will catch them and call them errors. And the second thing I want to do is integrate chunked body into the client request processing in my library. And that should let me use Rover, which is my little utility for HTTP client, to fetch content from web pages that insist on chunked transfer coding for the body, which we were having trouble with 2 streams ago. So let me get started. So we have tests already set up, but they're all positive use cases. Here they are here. They're all decoding valid bodies. A lot of them empty, a few simple, and a few that are not simple, and a few with trailers. So I think what I want to do is look at all the places right now where we have this state error and try to make a test case for each one. Basically wherever it's set. Okay, so here's where actually this is catching a lot of different possibilities. So if the chunk size line can't be decoded. So let me just make some empty test cases. Fill them in after I have them all kind of laid out. So decode trailer, no, not decode trailers. So decode bad chunk size line. And then I'm putting 3 dots there because I think I want to have multiple tests for different kinds of bad chunk size lines. Okay, next we have, while we're expecting the chunk delimiter, we do not see CRLF. Actually, I'm wondering if that's even possible, because we don't get into the state until oh no, we do get into the state. So this is where let me pull up the standard again. This is one of those funny things that I'm not sure why they put it into the standard other than making it easy for human eyes. If you look at section 4.1 transfer coding for chunk transfer coding, they say at the end of chunk data you should have a character turn line feed. I don't think that's strictly needed because chunk data is always exactly the number of bytes specified by chunk size. So there's really no need to have a CRF for the machine. It actually makes our code a little bit more complicated. I have to have an extra state to match that. I think it's because if you're looking at it as a human, although this might look kind of like binary chunk, this CRLF will make sure that the chunk size for the next chunk starts at the beginning of a line. So anyway, to make sure that we're doing the right thing there, we'll have decode junk after chunk. Junk after chunk. All right. And then what else do we have as far as errors? Okay, we can have a bad trailer. So decode bad trailer. And what else? Nothing else. Okay, so let's go into bad chunk size line, see what are the different ways decode chunk size line can fail. Basically inside of here wherever we return false. Okay, so if we find a character that's not a valid hex digit and is not a semicolon, actually, let me think about this. What about character turn line feed? Yeah, what if you hit a character turn when you're in this state? Oh, it's already been removed, so yeah. So this is my template. We'll have decode bad chunk size line. Not hex digit. Let's use the same word, hex dig. Not hex dig. In chunk size, okay. And what else? Actually, I'm going to put this template at the bottom and then copy up and then fill in stuff here. So what's next? See. This window. Okay, it could be overflowed. So bad chunk size line, chunk size overflow. Okay. What else? Okay, we could have a chunk extension which begins with a character that's not a tchar. So chunk extension, first character not tchar. All right, and then what that's next? Okay, then I can see right away a character that's not a tchar equal or semicolon for the chunk name and not the first character. So chunk extension, not first character, not tchar or semi or equal. It's okay to have ridiculously long test names, by the way. I don't know why I keep going back to OneNote, but I am. All right, and then chunk, it's same thing for chunk extension value. So chunk extension, actually this should be name, right? Because we'll have now value first character, not quote or tchar. Those are the requirements, right? Yep. And then state for can fail if it's not a tchar or a semi. So chunk extension value, not first character, not tchar or semi. All right. And then we have inside a quoted string, we have the characters not allowed inside a quoted string. So chunk extension value, quoted string character, how about we'll just say illegal character. All right. And then we have, okay, there's a difference between it being a normal character and then the second character of a quoted pair. Actually, how do we even, oh, okay, if it's double quote, I mean, if it's backslash, it's a quoted pair. Okay, so it's chunk extension value, quoted string, bad quoted character. All right. You know what it is I keep hitting Alt Tab and it goes back to OneNote instead of hitting Control Tab. Okay, the next return false after this one, right? Right, is the next character after the last extension. So we can only get into this if we get the ending double quote of a quoted string chunk extension value. So let's say character following quoted string extension value, not semi. Well, let's say semicolon. make my test names even longer. I wonder if there is a point at which the compiler will say that name is too long. Okay, and then it's kind of subtle, but you could return false if the state is not any of these. So that would be state 1, 3, 5, and 6. So what's state 1? Let's modify the template here. Bad end state. So that'll be our template. State 1 is we're expecting the first character of an extension chunk name. Expecting first extension name character. Alright, and then next was state 3, I think, right? Yeah, state 3, the first character of an extension value. Expecting first extension value character. Alright. State 5 and 6. So 5 is expecting either the end quote or a character inside a quoted string. So we're inside a quoted string. So unterminated quoted string extension value, not quoted pair. And I'm going to copy the last one. We don't need the template anymore. So it'll be quoted pair. All right, so that's quite a lot of negative test cases, but not too bad. So let's just take this very simple 3-liner from, what was that? Decode simple empty body one piece, and we'll just work with that. So bad chunk size line, not a hex digit, so something like G or something like that, right? So what to expect? Actually, I'm not sure what decode will return. Let's see, what does it return? It'll be in this state. It'll find the line ending, so it'll accept all the characters in that line. So it'll be however long that line is. So that's 4 characters. And it'll be error. Alright, okay, next one. Chunk size line, overflow. So I think the easiest thing to do is to just hold down the 1 key. And how many characters is that? So we're in column 31. If I go to here, column 94, that's 63 characters, 64, 65. All right, next. Chunk extension name, first character, not T character. So extension, and then the name is not a T character. What would be not a T character? Actually, we can just look at our own code, right? T char. So something that's not in this set. I'm just looking at my keyboard. What keys are not in this set? How about the @ sign? So @ 1, 2, 3, 4. So that's 5 characters. First character, not first character, not tchar, semicolon, or equal. Actually, that reminds me, I can also do a similar test here for if it's just another semicolon or an equal. Hey there, Raleigh Monkey. Thanks for the bit. Bits. 2 bits? 2 cents. 1, 2, 3, 4, 5. Okay. Not first character. So the first character has to be some tchar. How about X? And then not a tchar or semi or equal. Okay. 1, 2, 3, 4, 5, 6. Now a value, first character, not quote or tchar. So let's say equals that. 1, 2, 3, 4, 5, 6, 7. That's 7. Not first character, and it's not a T character or semicolon. Oh, I should make a test where it's semi. Okay, now Y, Z, or Y at. Something like that. Okay. Quoted string, illegal character. So quoted string, illegal character. How about, what's an illegal character? How about \x? Actually, how about a backspace? That's not legal. Pretty sure. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Did I count that right? 3, 4, 5, 6, 7. Yep. Okay. Quote string, bad quoted character. So it would be quote and then something that's, I think, like not in that set. What's the set? Quoted pair. Right, it has to be a tab, a space, or printable character. So like again, like a backspace would do it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Character following quoted string extension value, not semicolon. So something like a valid quoted string like Y, and then not a semicolon. So how about Z? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bad end state, expecting first. So if we end right there. 1, 2, 3, 4, 5, 6. Expecting first extension value character. Oh, this was the name character. So it's if we end even earlier. And then this is expecting first value character. Okay. And then unterminated quoted string, extension value not quoted pair. So that would be that we just end right there. 1, 2, 3, 4, 5, 6, 7. And then a quoted pair. So add a quote, double quote. I'm not a double quote, a double backslash. We'll make it a double backslash because any backslash character in a C string like this is an escape character. So 2 means that we want to put backslash into the string. We have to escape it because it's itself an escape character. Right? So this was character turn, this one's line feed, this was a single backslash, and this is a single double quote. It gets a little bit more crazy when you mix that with regular expressions, which have their own escape characters. Okay, decode junk after chunk. Chunk after chunk. So let's make a valid chunk. Something like 1. Enter, and then like X, but then we have some junk. Like that. 1, 2, 3, 4, 5. It's going to read 5, isn't it? Actually, 1, 2, 3, 4. No, it's only going to read 4. Don't just love reg expressions. Reg expressions are evil. You shouldn't love them. You should only use your powers for good. All right, bad trailer. So let's make a trailer. We can have an empty chunk with a trailer, right? So what kind of trailer would be bad? Something just has, how about something doesn't have the colon in it? Right, so that would be a valid trailer. That's not a valid trailer. we have to terminate it, otherwise it won't even parse that correctly. Right? Actually, it won't even get that far. It should not, it should accept that. Actually, let's see. I'm not remembering what message headers does. If this was a valid header like that, it wouldn't actually accept that until you had another line after it, because it does look ahead. But if it's broken like that, actually I'm going to guess that it doesn't accept any of these characters, so it's only going to accept 3 characters, and then go into the error state. Let's try it out. Very low probability that I actually got them all right. That's fine. T-test filter equals, it's going to be decode bad something. Actually, I have junk after chunk. I want to catch that. What if I say bad junk after chunk? Just so that my filter will catch it. Okay, 12 passed, 3 failed. So bad trailer failed. Oh, okay. I guess it didn't actually parse it. Let's add, if I add an extra new line, character return new line, let's see if it actually decodes it to an error. Okay, it actually accepted that second line. Right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, it accepted everything. 16. All right. It said it was complete. That's not good. This should have been an illegal header. Let's look into that. All right, so step into that. So we're going to read our last chunk here. And it's going to go to decoding trailer. And then the input is xfoo space bar and then 2 end lines. So we're going to step into that parse raw message. Okay, it finds end of line. Okay, here we go. Valid is false. Oh, it goes to state complete but sets valid to false? I didn't check that correctly. Ah, okay. It's able to parse the whole thing and come to completion, but it's not checking that it's false or valid. Valid false. So we should do that. If impl trailers is valid, then it's complete. Otherwise, it's an error. Okay. So we did find a bug. So let's see, the other 2 failures are first character problems. Oh, interesting. It's returning extremely large numbers. That's probably a bug as well. It'll be in the decode chunk size line, right? So let's set the correct breakpoint and just look at that. Line 263. All right, so go. Step in fully. Oh, hold on. It should not be 7. What did I do wrong? Oh, okay. We're trying to pass it more data after it's been given data, so it's going to end up truncating. So before we do that, we have to reset the body. How come I can't do that? Oh, well, we want to be able to do that. Let's fix that. Yeah. There should be no problem with doing move. We just need to default implement it. Okay. Oh, wait a minute. That's because this goes here and here. There we go. All right, and then we have to do that there. And it's probably why this test failed as well. I bet. Yep, that was it. Cool. Wow, 112 tests. Quite substantial. All right. So we did 2 essential things in addition to making negative test cases. So fix issues found by adding negative test cases. So allow move construction assignment of chunked body. That's one issue. The other issue was invalid trailers. Detect invalid trailers and handle by struggling with English words here. Marking the chunked body as marking the chunked body decoding process as being in the error state. That's a bad description, isn't it? How about failing the chunked body decoding process? And then we should say add a test case for every category of failure mode in the chunked body decoding process. Okay, cool. Hold on a sec. I need to just for a moment block out my capture. It's gonna go black for a second. Don't panic. All right. Just getting a little bit more comfortable with OBS, and one thing I want to be able to do quickly is blank the screen when I do things like bring back up my email, because I want to make sure I don't actually accidentally capture my email on stream. Okay, so we're going to move on to the next thing, I believe. Because we added the negative use cases, now let's try to integrate it into client request processing. This will be fun. So we're going to move into client tests. And I say the this will be fun, sort of as a joke, because this is only really fun if you're into low-level C++ network stuff. If not, hopefully you're picking up a thing or two about programming or just listening to my voice or whatnot, but I don't expect it to be fun for everybody. Okay, so we have a lot of test cases for parsing different kinds of responses. I think what we just need to do is add one for a response that has chunked transfer coding. So maybe this first one here. Yeah, let's just modify this one. All right. Parse, we'll rename the original one, parse get response. Body with content length. With body and content length. And we'll name this one with chunked body. All right, so all we need to do is strike, well, not strike the content length, but replace content length with transfer, I think it's transfer coding? Chunked. But let me verify by looking at the RFC. Chunked, okay. Rolling. That's my computer, not yours. I still have to change my audio so that I use non-default sounds. Okay, it's transfer encoding. Wonder why they say encoding sometimes and coding other times. I have the same issue. Sometimes I write down coding and other times I write encoding. Okay, so it's chunked. So to turn this into chunked encoding, let's be a little bit creative. So we will first break them into separate lines. Like, doesn't really matter. Something like that. So we'll have 3 chunks. We just need to measure how many characters are in each one. So that's column 22 to that's 12 characters. So 12 in hex would be C, correct? A is 10, yeah, C. Right, and then we need to put a character return at the end of each chunk. So that's the first chunk. Second chunk goes from column 10 to 32, so that's 22. Okay, so I can't do that in my head. I should be able to, but I can't. So 22 decimal 16 hex. Let me put that off to the side. 16. Character return. And then the last chunk goes from 10 to 29. That's 17. I can do that one. That's 11. And then an extra character return line feed. And then we need a 0. And then we have a final termination. Actually, let's throw in some trailers. Because what we expect the client to do is take the trailers and put them into the headers. So let's, I don't know, pick one of these, like, you have to be careful because the standard is pretty picky about what you can and can't put in a trailer. Where do they say that? Okay, we should generate a trailer header for the message body to indicate which fields are present in the trailers. Okay, we should do that. And I wonder if we have to put this in our requests. I think this is the part that I was looking for. So, must not generate a trailer that contains a field necessary for message framing. So we can't put host in there. Not that host is in there, but... So controls and conditionals would be what? None of these. Okay. Authentication, response, control data. Do we use any of those? Vary, so we can't move vary can't go in there. Expires date. Date can't go in the trailer. Okay, and we can't put content type. We can't put content type in the trailer. Range, encoding. Obviously can't put that on. What about E tag? Can we put the E tag in the trailer? Unless the request indicates a TE header field indicating trailers, server should not generate trailer fields it believes are necessary for the user agent to receive. Okay, well let's just add an extra one. So xfoo bar. And so what we should do is we're going to have the same body as expected, but we're going to add another expected header. Sound good, right? So obviously this will fail. Let's actually see what happens. We should see the same kind of result that we were seeing in Rover. This test is named something with chunked body in it. Okay, so it fails on 435. So all of this actually got, but it didn't get that. Let's turn this into an expect, and these are sort of redundant, aren't they? At least in this test they are. And I think I can just turn all these exerts into expects. We don't need that one. This one we should probably keep, because these are not valid to check if it's not a complete response. I just want to see all the places where it's failing. Yeah, so it did not see the xfoo header and thought the body was empty. Right, so when it saw that and then decided what to do for the body, it said, well, there is no content length, so there's no body. Even though it should have seen that, and then so, okay, there's a chunked body that follows. So we're going to add that. That is in client. Actually, is it in client or is it in response? I think it's in response, where this is really done. Do we have response tests? We do have response tests, so maybe I should have put it here. Quest tests? Oh, maybe it's not in response. I think response might be just a structure. Yeah, okay, so it is in client. Parse response, right? So this goes to parse response impl, which does all the stuff. So here's where it's extracting the body. So this is an anonymous function, but it operates on response. So we need to put the chunk body somewhere. Should I put it in response or should I keep it separate? I think we have to put it in response. That's the only state we really have. Well, the transaction could have it. But here, the only state we have is the response. Actually, we could, no, we don't even have state. Here, we made our own response. So I could keep it separate. Essentially, I could make parse response impl require a chunked body. And then we have to make that HTTP, and then we're going to have to include HTTP chunked body. I'm leaning against putting the chunked body in the response because that chunked body is really just a utility that we're using to parse the body. The actual response has an actual body in it, right there. This is merely a utility for parsing it. We need to keep it as state because parse response simple can be called incrementally. Call one or more times. So it'll be another side state helper thing. Chunked body. This is used to incrementally parse the response body if the response employs chunked transfer coding. All right, so we need to make one of these in all the right places. So this is transaction, so I think we can just say chunked body and put it alongside response here. This is a utility used to decode chunked bodies of responses obtained from the server. To decode the body of the response obtained from the server, if the response employs chunked transfer coding. That's better, maybe. All right. There was one more place, wasn't there? Down here, yes. So we'll just make one here. So chunked body, and then we just pass it in. So in this use case, you have to have the complete response, otherwise you get null back. So this really is just a temporary utility. Okay, so we have that chunked body. Now we need to try to use it. I think what we'll do... Oh, my printer is just beeping. Why is my printer beeping? Oh, it's just decided that it ran out of cyan ink, even though I haven't printed anything all day. Actually, that's a data point in favor of something that I read a while back, which is that printers don't actually track how much ink you really use. They have little timers that they slowly tick down, and when they reach 0, then it tells you it's out of ink, but it's not really out of ink. I mean, if I haven't printed anything all day, why would it just say suddenly now that it's out of ink? It's a big scam, isn't it? Printers and printer ink. Anyway. So it's an else to this, right? So right now there's one big else that says there is no body and we're done. So let's add one. If the response headers, we have a nifty thing here, right? Get a has header token, and it's transfer encoding. Has the token chunked. So if it is chunked, this byte's available for body, we just pass it in, I think. Oh, we might have to have a temporary buffer for if the bytes aren't accepted, though. Oh, this returns how many were accepted, so we're good. So what we can do here is say chunked body dot decode the input string was what? Next raw response part. Offset. Here's where we might actually use this offset. So where is it? Message end, I think. Yeah, message end. Oops. Message end. And then the length. Okay, 0 will default. Is that defaulting to the correct thing, by the way? No, it's not. It should be length minus offset. Although, we really won't see the problem. If this, for substring, if the length goes past the end, it just goes to the end and stops. Really, that's a problem, though. We should have a, I should do a little bit of a, here, we'll do a little bit of a side thing. Chunked body test we need to have a test for wherever we did, where do we do where we decoded using offsets? Was it this one? No. Where was it? It was the one where I had A, B, C. Or X, Y, Z or something. Yeah, there we go. Yeah, this thing. Well, let's make a new one. So this will be decode. Let me think about this. Actually, you know what? I don't even think I need to add a test case, because what's the worst that can happen? Length will be way too long. It'll just get truncated. That's the only time this length is actually used is there. I think we're actually okay. Let me check the manual to be sure. Checking manual. CPP string. No, why did it go to, oh, because it looks up headers now too. I want basic string substring. And what if count? Oh, look, we'll get an out of range exception. So this will cause an exception. So we should have a test case for it. Put that back, please. Did I already lose it? What if it's in my clipboard? Ah, it was in my clipboard. Yay. Okay. So decode input length out of range. So something like if I say 1,000, right? I bet if I ran that now, I'll get an exception, an uncaught exception. Oh. This needs to include. Someone just came home. Let's see. I am forgetting to include chunked body. It's what I'm forgetting to include. All right. chunked body tests. Oh, 5? Okay. I guess it didn't throw an exception. Did I read that manual correctly? Oh, if it's pauses out of range, but... Okay, if the requested substring extends past the end of the string, then it goes from pause up to the side. Okay, so so it doesn't matter. Okay, that is completely, I don't even need this test. No, there was no problem. No problem, nothing to see here. We're going back to here. Which means all along I was like wondering, what do I pass for length here? I don't have to pass anything. Because I want to decode all the way to the end. Right, because that's what the bytes available does. And what it accepts, I think I want to add that to message end, right? And then we'll say if chunked body dot get state. Maybe I should do a switch here. Case chunked. Hold on, I'm gonna adjust my mic. Chunked body state. What happened here? Oh, we're in the anonymous namespace, so we had to qualify that in HTTP namespace. Okay, so we could figure out which states there are, or I could look at this. Actually, I really don't care about all these states. What do I really care about? Complete and error? Complete. Error, and then we'll have a default case which does nothing. Is this inside of a loop of some kind? No, it's not. Okay, so if it completes, then we say response body equals chunked body, which takes advantage of the cast to standard string. Error, we can just say it is an error. And then we'll naturally just return message end. Default just returns message. Okay, so this should work. Let's try it out. I actually thought the integration would be a lot more, so maybe I missed something. Okay, I did miss something. So client tests chunked body. Oh, the header isn't being transferred. We should do that. And this is where we got to be careful. We got to follow the rules, right? So I think what we'll do is we will iterate over all the headers. So for const auto, well, trailer in chunked body dot get trailers get all. Right, it returns a vector of them. So trailer. So right, if I'll just type what I was thinking. It would be something like if allowed trailers dot find trailer dot name is not equal to allowed trailers dot end, then we would add it. So response dot headers dot add header trailer dot name trailer dot value. Something like that, but I need to be careful because we don't want to just... Oh, my printer's like really doing something right now. I think it's like calibrating itself. It has its mind of its own sometimes. Okay, here are the rules we need to be careful of. Okay, we're the receiver in this case, so we're the recipient, so we don't really need to really care about the sender's rules, unless it says the recipient must ignore illegal ones. May process them as if they are appended. It must ignore any fields that are forbidden to be sent. So thus, this allowed trailers, if it is not found, it won't add them. Okay, unless we included a TE header, server should not generate ones that feel are necessary. They might be silently discarded. Is that it? Oh, I forgot about this stuff. I don't think it says it explicitly in the text. At least I didn't see it, but in the algorithm pseudocode, they did show the content length as being set. So maybe we want to do that. So that would be in our tests for client. Interesting. So there was a content length, but we never checked it in our original test. We should do that, right? Content length. $51. We should kind of expect it here as well. So even though there was no content length in what we sent, we're going to expect that the client fills it in like the pseudocode says it should. Also, we should do this. We should make sure that the chunk was removed. So, oh, that can be an expect. So we can expect false response headers dot as header token transfer encoding chunks. Yeah, my printer's bugging me again about running out of ink. Hey, Fathom. Out of curiosity, what am I using for my cross-platform socket layer? I'm sort of reinventing the wheel, I suppose. I'll show you. It's this library I named System Abstractions, and in it there are two classes, connection and endpoint. Network connection, network endpoint. So network connection is sort of the abstraction for sockets. So it has methods like connect, and you can pass an IP address and a port, and process, where you just tell it to read and write the socket, and you give it a delegate to call when you receive data and if the connection is broken. And then you can call is connected, get your address. You can call send message to send data, although it really just puts it into a queue, and then the process worker thread actually does the sending. So this is the abstraction, right? And the way it's implemented on Windows, for example, would be using a socket with WinSock. So where would that show up? I guess it would be in the internal header. Yeah. So here it's a WinSock socket. So sort of reinventing the wheel in that I'm sure there are other cross-platform socket layer libraries out there, and I'm not using them, so I'm reinventing the wheel that way. But also sort of not reinventing sockets. We're leveraging WinSock on Windows, and on Linux I use just BSD sockets. And so that was network. Actually, that's endpoint, isn't it? Network connection looks the same thing. It's got a socket. the difference between network connection and network endpoint. Network connection is for client side and network endpoint is for the server side. So on the server side, you say open, and you're basically opening a port and then listening for incoming connections. So you get a delegate if a new client connects, and then also it supports datagram mode too. So if you open it in datagram mode, there's a delegate when you receive a packet, and it has similar thing for send packet for datagram mode. Otherwise, you basically sit there and wait for new connections to come in through this delegate call. When I say delegate, by the way, or if I have the word delegate, it means the same as callback. So how am I handling the select limitations on Windows and whatnot? So on Windows, let me find that. On Windows, I think I am using, WSA event select. So what that does, it's like doing a select behind the scenes, but when the events become true, I guess, it sets a Windows event handle. And then I use, where is it? Wait for multiple objects. And I'm waiting for either the socket event, which I set with WSA event select, or I'm waiting for the state change event, which I use internally whenever I do things like I tell it to stop waiting, like to close or whatnot. So yeah, this is on Windows. It's wait for multiple objects and WSA event select. On Linux, it's going to be different. Let me go over to the Linux side. Oh, and by the way, this code is all in GitHub if you want to take a look. There's a link below to like the main repository, and then the main repository has this either get XML or main XML, and this like system abstractions. You can see the link to GitHub for that. You think unless I use IO completion ports tend to be limited to 64 concurrent handles? I actually haven't tested that. I don't know. That's maybe something for me to look into. That might be a good idea for a stress test, right? So are they limited to 64 concurrent handles? Because we don't use IO completion ports. I'll check that out later. So the Linux side of things. Where are you? Oh, it's under POSIX because it's shared between Linux and Mac. There, it's all again in the processor thread. I do use select. Here's select. And I have two things I'm waiting on. The actual socket, and then I have a special handle. It's like a pipe that serves as a combination of an event and it's an event that has a handle. It's called pipe signal. So you can set it, and the set is done by writing to the pipe, and you can get the handle to use with select, and clear is just reading the pipe. So I use that as a handy way to select on both that handle, which is really a pipe, and then the actual socket. Yeah, I'll have to look into if there's a limitation of 64 handles. That would be a problem on the server end, I guess. Because on the client end, I don't think I'm going to ever open up 64 handles. Then again, do you know if the 64 concurrent handles, is that for select and this wait for multiple objects, or WSA event select? Or like if I tried to wait on more than 64 at a time there, or is it process wide or thread wide? Because what I do in my library is every socket or every network connection or every network endpoint runs its own thread. So there'll be a thread for every connection, basically. So if it's not a per process limit. If it's a per thread limit, we're okay because there's a different thread for each one. Which might lead into another problem, right? If I have, there might be a limit to how many threads you can have. So I hope I answered your questions. And I'll definitely look into if I have a concurrent handle limit that I don't know about. So yeah, I'm going to expect the client to remove the chunk transfer encoding token because that's what the spec says. Remove trailer from existing header. Okay, trailer. Why is that? What's the trailer field trailer header used for? Trailer. When a message includes a message body encoded with chunk transfer coding. Oh, okay. So we're supposed to remove that. So the limit is for the number of handle sockets you pass. Okay, yeah, so it might not be an issue there, but I wonder if I'm running into an issue with having a thread for each connection. Like, what if I had 1,000 connections? Can I have 1,000 threads? Or am I going to run into some other limit? I haven't really tested it. Okay, this says that if we send a response with a trailer, we should have a trailer header that lists the names of all the fields. And this pseudocode here basically says we're supposed to remove it. So I guess we'll just do that. So we'll put in trailer here somewhere. Xfoo. There, we've listed all of the fields. And then we will expect false that we have the header trailer. All right, so let's do the things. So we need to response headers dot remove header trailer. Response headers. I have a add. No, I don't have a add header token. I have a remove header, and I have a has header token. Oh, I have a get header tokens. Do I have a set header tokens? No. I basically want to remove chunked from transfer encoding, but retain the rest of that header. Yeah, C10K problem. I did have a link to that. That's in my notebook somewhere. Thought I did. Thought I linked to it somewhere. Should be only in this notebook. Maybe it was only in chat. I was talking to someone in chat and I gave them the link to that. Yeah, but I know which one you're talking about. It's probably in my history. Yeah, see, it's in my history already. This one, right? Since I did not put it in the notebook, let me put it in the notebook now. I'll say probably not, but we may have issues with lots of threads. Lots of threads. See that. Yeah, so I read through it before, but I haven't really applied it to this project on stream yet. I mean, it's more for where you're gonna do something serious, where my stream has been mostly just playing around. But yeah, if I ever want to do something serious with this stuff, I will definitely have to do that homework. Okay, I thought I had something already in the server maybe where I would take out a token or add a token. Let me look for that because that would speed things up. Not in system abstractions. Server. Something about the close, I think it was. Actually, I don't think this is correct anymore. Yeah, this is going to be a problem. I probably have a note to fix that, but let me make sure. Let me make sure I have a note to fix that. I don't. Okay, let me add a note. So, server. I think I'm not doing the right thing searching for close token. Calling, what am I calling? Get header multi-value? Rather than what I should be calling, which I think was something about tokens. Get header tokens. But anyway, not to get sidetracked, I was looking for close. Yeah, all this might be wrong, actually. Where am I calling get header tokens? Really? Okay. Alright. Well, I thought I had code to do this. What I want to do is get the list of tokens, remove chunk if it's in the set, and then reconstruct the header without it. So I guess what we'll do is this. Auto transfer codings response.headers.get header tokens transfer encoding. Just to make sure. Yeah, it says remove it from that. Not to remove it from the header fields, but just to remove that token. The transfer codings is a vector, yes. So we're going to find it. The const auto chunked token. Okay, why didn't it like find? Vector doesn't have find. Okay. Well. This is where I would like to be in a language like JavaScript. I want either a find or a filter, but I'm guessing vector doesn't have such a thing built in. What does it have for me? I can erase, but I need an iterator. How do I get an iterator if I don't? I guess I'll have to search for it manually. Standard find? Oh, yeah, you're right. I always forget about that. But I have to do first to last, right? Yeah, we can do that. Thanks for that. I just have to give it the range, so transfer codings begin to end. And although we already did a check to make sure it's there, we should just sanity check here. The only if that is not equal to transfer codings.end. Actually, it doesn't matter because I was going to just say transfer codings.erase, erase it. If you erase the end, it doesn't do anything. So I can just do that. And I could even collapse and just erase whatever find tells me. But I'd rather make it 2 lines. And then we're going to set the header. But we have to reconstruct the string value. I think I had a string helper for that. See if I remember what I made. I think it was system abstractions. Join, yeah, it was join. A vector with the string, right, so my vector is transfer codings and my string is space. Yeah. Alright, so I just need this allowed headers. Actually, there's going to be a lot of allowed headers. Maybe I should turn it around and say disallowed? Disallowed. I don't want to say they're illegal, because they could be legal in other context. I guess I could use a longer name. Headers not allowed in trailer. So specifically, if it's not in that list, we can add it. So we just need to define that. Here's a good enough place. So vector of strings. These are the names of message headers which aren't allowed to be transmitted in the trailer of a chunked body of a message. Alright, so let's go through the list. A list of the disallowed ones. So, transfer encoding, content length. Well, that's EG. So there might be other fields necessary for message framing. So routing, host. I'd really like to have a complete list. I wish they would just give me the list. Plus, here they do give me a list, so I can just copy these. Cache control. Expect. Okay, they already had host in that list. I'm going to keep it in the same order in which the RFC actually listed them, but I'll have host, but I'll comment it out and say already not allowed by explicitly. Already explicitly not allowed by section. What was that section again? 412. And this was controls and request modifiers. Oh, it's specifically controls and conditionals. Message framing. As listed in section 412 of ours. Okay. Already explicitly listed earlier. Oh, already explicitly listed. Explicitly listed earlier. Okay. Max forwards. Makes me think of max headroom for some reason. That's how my brain works. Range and TE. And what else? Authentication. Really? All of that? It's going to be a lot of headers not allowed by authentication. We have a list somewhere. Here, there we go. Authentication. Authorization. Proxy authenticate. Wonder if I should just copy paste so I don't misspell it. That'd probably be smart. And iSmart. Okay, there's the other standard as well. Okay, this has this section near the end, hopefully. So, okay, it's cookie set, really cookie. You can't put a cookie in the trailer? Cookie. Set cookie. Now I'm hungry. Cookie 2? I never heard of this one. I didn't know there was a cookie and set cookie 2. Which RC is this? State management. Why do they list that as part of authentication though? Anyway, response control data. Age, cache control. Actually, we should be checking case insensitively, shouldn't we? Date earlier, no. Location, retry after, vary, and warning. I think I had a class for that, didn't I? It was like message headers, header name. Yeah, that has a case insensitive comparison. Right, this one. Yeah, so we're going to use that. Find should employ that comparator, hopefully. Okay, or determining how the payload. So content encoding, we already listed content length. Payload processing. Content encoding. Content type. Content range. And trailer. Well, that's obvious to me. Okay. It worries me that it says EG, which to me means for example, which means it's not an exhaustive list. But I don't know. Maybe I won't worry about it right now. I'll just leave that the way it is. Let's give that a try, as long as this compiles. I see it might not. Oh, it's the same problem, isn't it? So we'll use the same solution. Whoops. Using generic... Oh, generic find needs algorithm, doesn't it? So it's this begin to end this guy. Actually, you know what? We could make use of a better data type for that. I could use set. And then I could go back to using this dot find. Right? Yeah. That should be faster too. As long as this builds. Okay, it's not building. What did I do wrong? Okay. What's going on? Again, it's a problem with using the standard template libraries that I don't think the tools should do this. They should be better. There's nothing wrong with the standard template library here. It's my use of it, so it should tell me where I'm using it as the primary position of the error. Instead, it makes me search through and find it here. Okay, I can't make it a set because why? Because I don't define the less than. Okay, well I can do that. Let's do that. So, header name. Let's make a less than. Operator less than. This is the less than operator. Not the... How does it work? This is less than right-hand side? Yeah, right-hand side. This header name is considered less than, what does that mean? Lower rank? I can't remember if it's lower or higher. Then the header name, given header name, is returned. Well, it's already... We'll say that in... The names are compared... No, are compared in a case insensitive manner. Okay. So it's going to look much like the equality operator. Only we do something a little bit different here. So if it's less than, then return true, I believe. Or is it... Like, it doesn't really matter. We can arbitrarily say the ranking is, if it's fewer characters, it goes first. It's probably nicer, though, to do this. To do character by character, and if we exhaust one or the other... Right, so only if we exhaust one or the other should we do that. So that means we should do a minimum, which means I need algorithm. The minimum of the left-hand side and right-hand side. If it is less than, actually let's left-hand side char equals to lower name I. Just so that I don't have to do that twice. I can say else if it's greater than, turn, actually let's make that true and make that one false. By default, if they're equivalent, they're not less than each other. Okay, so if we exhaust one string or the other, then it's gonna be by length. So if it's less than, it's lower rank. Do I want to do the same thing here? Sure, why not? I watch other streamers and they're a lot better than I am at mastering their keyboard shortcuts. I don't know why, but the last 10 years or so, I've gotten pretty sloppy as far as memorizing keyboard shortcuts. False. Actually, it doesn't matter, right? Which means I didn't have to do all this mess. Well, I'll keep it in there. Maybe it's easier to read. All right, so then it should build now, right? I should probably do the right thing in making some unit tests and message header tests for that. As long as I did the same thing for the header name equivalency. I didn't. It's never too late to add it in, so we'll add it in. So this would be header name equivalency. So let's do this. So struct test vector, and then const standard vector of test vector, test vectors, and for const auto test test vectors, expect equal, yeah, test vector dot result for test vector left hand side equals test vector right hand side. So that means we need to have a result. How about expected result? And then we need a left hand side, so that would be message headers, header name. And the right hand side. I could do that, but I usually don't like to have more than one variable on the same line, even if they're the same type. So let's have some true ones. So hello and hello. Right? And we can do both when they're identical, when they're not. Actually, that was a good test. Actually, this should be false. And how about when one's missing a character? L. And then I'll keep it like that. Now it's rank. So expected results. So rank of those, they're the same rank. This one, capital letters have lower ASCII code. Oh no, wait a minute. It's what am I thinking of? It's case insensitive, so it's again false. J comes after H, so did I get that backwards? This should be false. Did I get that backwards? Yeah, so that'll be false. If I turn it around though, it will be true. I should turn these other ones around as well. It should still be false. That I don't need to turn around. So they're equivalent exactly. These are equivalent by case, and either way. These are not equivalent, but they have different rank. And same thing here. So if I turn this around, we were saying that this should be true, right? Because its length is less. This is false. Okay, so we just need to make that a less than. And let me run that. Message headers test debug message headers tests. Now did it actually run the ones that I made? So that was header name stuff. Okay, cool. All right, so that means that we can run our client test now too, right? Oh, I forgot to set the content length, I think. Client, right? It's where this was used. Yeah, we removed transfer encoding, removed the header, but we didn't set the content length. Let's do it here. So response.headers.set header content length system abstractions printf zu response.body.length. That's long line, so I will split it. I'm kind of pedantic when it comes to splitting lines, although actually maybe not. This one, I don't know, I go by feeling, so I don't feel like wrapping that, but I felt like wrapping that for some reason. Cool, so we are passing the tests now. Awesomeness. So let me run everything. Let's run all the things. If that's good, we will check in the code. Which means now Rover should be able to read results from Google that it couldn't the other day. So we will give that a try in a moment. So I did change message headers. I added ranking of header names, and that was to get set to work. Okay, actually I'm going to check in the test for equivalency separately. We really should have had that one before. I don't know why I didn't do that. Probably because I was lazy. Stage those lines. So add unit tests for header name equivalency. Oh, amend that. It's just a test. Okay, and then we added ranking of header names values. Okay, we can push that, and then we're going to move on to HTTP. Check that in. Okay, added chunked body to hold on. Why is it added in the header? Line 121. That didn't seem right. The property of a transaction and a transaction. Yeah, okay, that is a problem. We don't want it in. This transaction structure is like the public API. I don't want the chunked body to be visible publicly. I want it to be in the implementation of the transaction, which is a derived class called transaction impl. That's where I want to put the chunked body. So yeah, that was a sort of a code smell. Right, so this is again a code smell. That should not need to include that header to expose the fact that I use that class. Right, so net zero change. Net zero change to API. Run the test to make sure nothing broke. Pretty sure it won't. So essentially, client add capability of decoding chunked response bodies. And push that. Okay, now let me see what happens now. If I run Rover, well, not run test, Rover to www.google.com. Huh. Oh, okay, yeah, this is problem number 2. There were actually 2 problems with Rover the other day. Let me go back to that. So the problems we ran into were chunk transfer encoding wasn't supported. So we just did all that today and yesterday. But this is problem number 2, which we still have a problem with Google.com with, is if there is no content length and is not chunked transfer coded, we're supposed to take all the bytes up to the closing of the connection to be part of the body. Really, it should say body. My code doesn't do this. And I see that as a connection close. So Google's saying it's going to close a connection after it's done with the response. But since my code is looking for either chunk transfer coding or content length and it doesn't see it, it's like, oh, okay, I'm not going to wait for the connection to close. I'm just going to say the body's empty and then we're done. So let me try to pick another website. I don't know, wikipedia.org. Just trying to find one that uses chunked encoding. That's redirected to, oh, TLS redirect. They basically want you to use HTTPS. How about Yahoo.com? That would be better. Again, HTTPS. Everyone wants you to use HTTPS. We'll do that in maybe a week or two. But until then, I just want something that does not... Okay, I have an idea. So this is probably doing connection close because we told it we're going to close our connection. I'm going to hack that temporarily. So when we do our connect, this fetch resource, right? We're saying false for this persist connection. If I say true, it'll try to keep the connection open. I think that triggers Google to use chunked encoding and leave the connection open. Yep, there it was. So before we weren't getting any of this stuff from Google. Now we're getting it all. So we're not seeing that. Actually, we are seeing, and I'm not doing the correct thing. It's leaving transfer encoding with an empty value. So it was chunked encoding. Yeah, so we should probably fix that. Anyway, it's working. We're getting a chunked encoded body response from Google now, which has, looks like some embedded JavaScript. That's what all this junk is here. Actually didn't know Google.com had so much junk in the homepage. I went to it to use it because, you know, one of my favorite sites in that it's very sparse. So I expected a small document, but I guess there's a lot of JavaScript behind the scenes. A lot of junk in JavaScript. I guess it's all JavaScript, that's why it looks sparse. There's hardly any HTML at all. A lot of junk. Anyway, let's fix the bug with the transfer encoding being an empty string. Actually, we should see that here. We should end up having that it has no transfer encoding. So that should fail our tests right now. Right. So we don't want to remove the header completely, but we do want to remove that token. So I suppose we'll have 2 tests. And in the second one, actually, I'm going to reduce this a bit. I'm just going to have the required ones. I think it's just date, content type, and we're not even going to test the trailer junk. I'm going to have chunked and I'm going to have foobar. I'm going to expect foobar for the transfer encoding. So it's still basically still there. And I don't need to check any of this junk. And I don't need have any body really. Well, empty body. Need to give it a different name though. Chunked body, no other. Well, yeah. No other transfer coding. With other transfer coding. All right. Oh, interesting. It left chunked in there. I wonder if it's supposed to have a comma. Let me look. That might be true. So where tokens are listed, I think it's this syntax here. Right, so there's a comma. So I forgot the comma. Okay, so the one with the other transfer coding passes. What's failing is that when chunked is the only transfer coding, it should just remove the whole header. So we'll fix that here. So it's here. It basically, if transfer codings is empty, do one thing. Otherwise, we're going to set it to the remainder, right? So what we're going to do here is just remove it. Okay, so now when I run Rover, fetch Google, and scroll up through the junk to the top. Now we don't have transfer encoding anymore. Content length replaces the transfer encoding. So it looks to the user the same as if it was not trunk transfer encoding, which is the whole point of the thing. It's supposed to be hidden away from the user of the client anyway. I need to look some of this stuff up. Like, this makes me curious. Like, why would you have a header saying, I guess this is content or something policy, this is not a policy? Why would you do that? This makes me curious. Okay, I think we're good to check that in. This was a bug. Yes. Client. Fix bug changing transfer encoding. In the changing, in the updating transfer coding. Completely remove the header if there are no other tokens remaining after removing the chunked token. We ought to make that a utility method of message headers. Let me make a note for that, because I imagine we'll use that elsewhere. To do message headers. I don't have one for message headers. Okay, let's make one. Message headers. To do. Add, let's zoom in a bit. Add utility method. Methods to add. Remove individual tokens from headers. All right. Okay, so it's 1:30 my time, and we've actually finished the whole plan, which is actually really good. I'm usually either way over or slightly over. This is a good problem to have, where I actually get my whole plan done and I'm wondering what to do next. Yes, so that's that. Oh, I know what we can do. I can remove the hack from Rover and we can see the problem and try to fix that problem. The only change should be in Rover, I think. Yes. So like, let's reset that one and then we'll rebuild and we'll examine this problem. This is the one where we are not persisting the connection, but we're also not waiting for the whole response body. So it's telling us we're not going to persist the connection, and it didn't tell us an encoding or a length, so we're supposed to keep reading until the connection's closed and then say that's the body. But instead, we're leaving early because, again, this code here, where we either look for content length or transfer encoding, and if the fall through is there is no body. So we need to do something where if close is in the connection header, we will basically read until the connection's closed. So two things, right? We'll accumulate data into the body in that case, and then we need to handle the body especially in the break delegate. Let's make a test for it. Always fun to like lay out the use case. So this will be a very specific use case, right? So this is receive whole body or response without content length or transfer coding. Yeah, essentially there's only one possible way for that to happen. That's where we set the connection to be close, right? So let's copy from this test case here. All right, so set up the client, yes. Have the client make a simple request. Oh, but I want to actually make it non-persistent. Actually, so I want to copy this unit test. This unit test is more applicable. Or really, should I just modify that unit test? Do I need a different one? Closed properly. Yeah, actually, we don't need a whole separate unit test. Well, hold on. This one had a content length, right? Let's keep that the way it is, so that we have a test for both content length and one that's almost the same, but without a content length. Without a content length, I think this test will fail because it won't even, well, we're not checking. We should do that too. Okay, where, I forget, how do I do this? How do I verify the client gave us, I guess it's this, right? So all this stuff goes here. 200, okay, text plain. Right, so we want to see content length of 8 with PogChamp. Exactly, so this should fail. HTTP test, please. And this is client tests transfer coding. All right. So this is exactly what we're seeing with google.com with a non-persistent connection. So we're not getting a content length. We're not getting a body at all. So let's fix that. We should actually make it a little bit more aggressive too. We should not transmit the last 8 bytes at first. Let's do it in 2 pieces. 2 pieces. Headers. Well, it's, what's it, like status line and headers? Body. So the body is, okay, so we can just say it's the end minus that length, right? And can I say this here? I think so. What I wanted to do is it should not be completed at that point. So I can put an assert false that it doesn't complete yet. Oh, wait a minute. Oh, no, that should work. These should be the last bytes of the message. Okay, let's see that fail. Right, so it's completing here before we even send the body. That's a pretty accurate assessment. It's thinking that it's done, even though it should be waiting for the disconnection. Where do we actually do the disconnection? Oh, and we need to do that, so... we need to do that here. Actually, what I'm going to do is, again, assert is not completed even there, but then we'll do the broken delegate. And that can be anything. It could be false. Then it should complete. Alright, so let's fix it. So it's in 2 places. So here where we're dealing with the body. We need to add another case, right? Else if response dot headers dot has header token connection close. Then response dot body plus equals this substring. Where is that substring? This one. Actually, we're going to do all this stuff. Not all of it, 2 of it, with a slight change in that we're going to add to it. And wait a minute, it's not... it's basically that, right? That to the end. And it's just this. Hold on, wait a minute, that's not quite right. It's this whole thing. Or I could plus equals, it's the same thing. But we're not complete yet. It should just gobble up any bytes as part of the body, and that's one part of it. The second part... actually, let's see if that... does that get our test further? I'm just curious. Okay, it does get the test further. It gets us to 1155. Right, so it doesn't complete the transaction until here, but it's completed, it completes as broken instead of completed. So this is part 2, right? When we break the connection, it's broken unless it's a special case where we're supposed to wait for the break and then complete the transaction. So that's going to be a special case in the broken delegate. Not that one. Is it here? Yeah, here it is. Broken, where is it? Maybe it is here. Oh no, it's this one. So, right. So right now, if the transaction isn't complete, we break it. What we should do is complete it for that special case. So if else, there are 2 things that have to be true. It's if transaction actually it's this particular state, isn't it? It has to be receiving the body. If it's that and 2 things, right? And those 2 things were it doesn't have a content length and it's not chunk transfer encoded. So transaction response, so it doesn't have a length and this is not true as well. It doesn't have that. Okay, so if we're reading the body and there was no content length and wasn't chunk encoded, then instead of broken, it's simply completed. Okay. Okay, content length is not getting set though. Why not? I thought we set that. Oh, wait a minute. No, we don't. No, we did that for chunk transfer encoding, but we have to do it here explicitly. Set header content length. I'm already thinking I want to break this line up to system abstractions printf cu transaction response body length. There we go. All right. Yeah. I'd like to see it pass. Okay. Ooh, we have some breaks though. Okay, so when the server is timing out, well, is that because we're using the client to test the server? Huh. How did I break those other tests? Well, let's see what this exception is caused by first. So that would be HTTP test. I want to make sure that it's not running any kind of filter. Okay, it is. So let's remove the filter and make sure it's going to stop on the C++ exception, and then just go. There's the exception. Okay, response is null. Interesting. So how come I can't look at the connection data receipt? Oh, okay. The debugger's kind of screwed up. There are too many classes called mock connection. No, there's only one. Oh, but yeah, okay. There's more than one mock connection within anonymous namespaces, but yeah, so Visual Studio's debugger gets confused about which mock connection class this actually is. We should have a data receipt, but it's thinking it's a different kind of class, so so this is not parsing correctly anymore. I guess our server is not generating a correct kind of response. Oh, is it because it's sending X? No, this is. Okay, this is the client sending a bit of a request and then a bit more. Okay, just to see this, I'm going to move this out. So this will be data receipt. This is just to aid in debugging. And I'll put a breakpoint here. So something's odd with this response. Okay, so HTTP 1.1.4.8 request timeout connection close. Looks good to me. Why is this not parsing correctly? Oh, I know. I know why. Because this parse response goes into this, it's like a helper. This is complete or error. Just looks at this current state, but it doesn't actually mark it complete if it was a connection close. So, Let's change this a little bit. So this parse response, for both of them, let's add an argument called final. I guess final is a reserved word, so final part. Final part. This flag indicates whether or not the given raw HTTP response message okay, final. Actually, we'll just take it. I'll take it all back. So we'll assume it always is a full request. Or I mean response, full response. So before, actually, does anything else call this? Hmm. The question here is if the response has been fully constructed, but the response doesn't really know if it's complete or not in the case of one that terminates at the end of the connection. I think what we'll do is we'll focus this a little bit. We'll say note. If the response is only complete when when there are not going to be any, let's see if I can write this English correctly. If the response is only complete when there isn't going to be any more data added to the response. Okay. This method assumes that if the response is only complete, this is terrible. This method assumes that if the response is only complete when there isn't going to be any more data added to the response, that it's complete. That's a horrible sentence. How do I reword this though? Okay, how about we say, this method assumes that no more data will be added to the response or okay. So with that note, I need to make sure that we're not using it improperly. Okay, this is potentially a problem because if we were, this is where we receive. Yeah, so we can't do this. Okay, forget it. What if I make it a parameter actually? Yeah, what if I do that? So param in more data, no more data. This like indicates whether or more data possible. How about that? This flag indicates whether or not more data might be added to the response. And we'll just default it. So bool more data possible equals true. Okay, so we have that special case, right? And we can just move it from where we had it here. Content, this one. If, well, hold on. We can say if state equals state error. Actually, if it's this, we'll return immediately. True, right? If it's in the body state, and if no more data possible, and in the body state, and the response doesn't have a content length and it's not chunked, then return true. Otherwise, return false. Right? So then I can use that here. If transaction response is complete or error. False. The transaction state is completed. The response might be an error. We're still going to set the content length, though, to whatever was received in the body. That seems good to me. So, this is complete or error. Those tests that were breaking before. Ah, here we go. So, we should augment the test here. Right, so here's a special case. So it's false. It's actually true if well, it's false by default, but it's true if there's no more data expected, right? Oh, I'm in the wrong class. Sorry. We haven't done this for requests. It's for responses that we've done this. If no more data is possible, then it is complete if we're in the body state because we haven't set the header. But if we do response dot headers dot set header content length to 42 or something like that, then we expect false. And it's true otherwise, like that. Same thing for if we, let's reset it. If we set transfer encoding to chunked, then it's not complete. Either way, right? Okay, let's try this out. This is response tests. Okay, so that's working now. Need to go through everywhere this is used and be careful that we set the correct value for the argument. More data is possible, yes. Not possible. Not possible. Okay. Okay, cool. So let's try client test again. All right, cool. It's working. Let's try all the tests. Cool. Fixed the breakage. So the problem here was is complete or error was not. That's okay, hold on. Before I start talking, I should get my complete thought. Okay, we did a bunch of things actually. It's add support for reading bodies of responses. Actually, let me make the complete thought here. Add support for reading bodies of responses which have no content length and are not chunk transfer coded, but instead should take in all data up to the point where the connection is closed, or in other words, no more data will be received. Okay, so what's the summary for that? Oh, actually there's other stuff here too. Okay, that's part of that. Actually, it's part of this support. So fix issue reading response bodies in certain cases. Certain use cases. Yeah. Good enough. Oh, did I forget to stage everything? Stage all the things, please. Okay. Commit. Okay, 2 o'clock. I actually need to end a little bit early, which is why I tried to start early on Wednesday, although I was a little bit late. I need to make sure I am done before 2:30, or at or before 2:30. We actually might be reaching a good stopping point soon. So if I run Rover again with Google, now it hopefully should read until the connection's closed. Oh, look at that. It actually did it. All that junk. Seems to be a lot more junk this time. And it set the content length. It's really nice. Okay, cool. I am happy. So now we should be able to read any website as long as it doesn't use TLS. That's going to be probably the subject of the next stream, because my roadmap, the short term was to fix chunk transfer encoding, so we did that. We fixed the problem with responses with no content length or chunk transfer coding. So we've finished all the short term tasks on the roadmap. So moving on to the medium term stuff, I want to experiment with libTLS from LibreSSL to add TLS support. That's transport layer security to the client. Transport layer security is the new age SSL. SSL stood for Secure Sockets Layer. Transport layer security is like a new version or revision, and the old SSL is deprecated. But some of the names of the libraries like OpenSSL, LibreSSL kind of have SSL in the name because of historic reasons, right? But it's going to be TLS that we're going to support. And I've chosen this LibreSSL library because it's got CMake support and I can build it on Windows, Linux, and Mac. And I just need to bring it into my solution and use it in Rover to try to add support to talk to web servers that require TLS. So we're going to be playing around with it. It's not going to be where I already know what to do. It's going to be like iteratively trying to figure it out, because there's not a whole lot of good documentation on LibreSSL or TLS. There is documentation in the form of the RFC for TLS, which I might need to read before I stream that. And there's obviously books on it, but LibreSSL I couldn't find really a whole lot, so I'm going to be kind of experimenting based off of stuff I find on the web. And so we're basically ready to do that. Because now we can read any web page that doesn't require HTTPS. What happens if I try to do HTTPS? Actually, it's just going to go to HTTP. Because Rover right now ignores the scheme. So it just goes to HTTP, port 80. Just because I have this tool now. What happens if we go to other web pages like twitch.tv? Yeah, see, a lot of them just, they either do a move permanent or they do a TLS move. What was it that did the TLS move? Was that Wikipedia? TLS redirect. Which is interesting. They use 301, but they have different reason phrases. But basically, they're both saying, we don't want to talk to you unless it's a secure connection. So go to this location, right? But Yahoo is willing to talk to us, right? Oh, I did yahoo.org, that's why. Interesting that yahoo.org redirects to yahoo.com. Oh yeah, cool. Yahoo doesn't like non-secure either. So what would take secure? How about CNN? No, they want HTTPS. I don't know. GNU? Okay, GNU.org is happy to talk to us. And it's a long page, so I'm going to do less. So yeah, they give us 29K HTML file. That's actually a nice example of something that gives us HTML without forcing us to go to TLS. And it even has a nice style sheet embedded in it. Almost looks like it was handwritten, which it might have been, for all I know. What happens if you try to go to twitter.com without TLS? Yeah, they want a lot of websites now want you to use TLS, so this is why I've been building up to adding TLS support. I shouldn't be saying S in there, should I? I don't know, I'm just playing around at this point. What other web pages might... Oh, it's like speedtest.org was happy to talk... No, it wasn't happy to talk to us. Huh. Maybe I'm getting the link wrong. What was it? Oh, speedtest.net. Wants us to go to www.speedtest.net. Right, which gives us a bunch of HTML. What I want is like example websites that give plain HTML. Example websites serving plain HTML. Static website examples. No, it's just examples and making your own. Well, I'm really just playing around at this point. One more. What's a website we could check? How about Mozilla.org? Really? How about com? There we go. Yeah, HTTPS. They actually give us a HTML page saying it's moot. Those other sites didn't, right? Like Yahoo. Actually, Yahoo gave us 8-byte. It said it was HTML, and it gave us this word, which is obviously not HTML. So someone at Yahoo needs to fix their site because it's not HTML. It's the word redirect. Interesting. Okay, what did wikipedia.org do? This is maybe more standard, like basically it's 301 and there is no body at all. Content length is 0, right? There's no body. Actually, I wonder if our code does the right thing. If there's no content length and we're not closing, and it's not a response that requires a body, does it do the right thing? Let me make the note of that. If a response has a status implying no body, and there's no content length, not chunked transfer coded, and the connection is not closing, what do we do? What should we do? Right now, the code will... Actually, I think the code will wait until the connection is closed. Collecting all bytes as part of a body. Maybe this is incorrect. Something I need to research. Alright, well, kind of running out of things to do before I tackle TLS, and TLS is a big subject, so I think I'll probably wrap it up early. Hope that's okay with you guys. We'll go host someone else. We'll see who else is streaming that I know. Okay, the corner piece is going, and he's an interesting guy to watch because he likes to work on all sorts of different projects. Sometimes Python, sometimes C, but mostly it's graphics based. It says he's working on a ray tracing engine, but I'm not sure. Sometimes his title doesn't reflect what he's actually doing, probably because he's going from task to task, but we'll see what he's up to. We'll go host the corner piece if you guys don't mind. So anyway, thanks for watching, and see you next time.